I want to take a minute here to talk about the relationship between our individual demand curves and our market demand curves. So obviously in a market, we have lots of individual consumers, and maybe they all have the same preferences or maybe they have different preferences. But to get market demand, we have to aggregate or add up all of our individual demand equations. So the way that we add them up is over quantity, right? Demand represents the relationship between price and consumption. So if I say at a price of 2, how much will be consumed, all I need to do at the market level is add up consumption at a price of 2 for each consumer within the market, and that will give me my aggregate consumption at a price of 2. So here we want to add the demand equations over quantity. So it's useful to start with our regular demand equations where we have quantity as some function of price. And sometimes that looks like X, right? X is our consumption good, or sometimes that looks like Q equals. So the first example I have here, we have Cobb-Douglas demand equation. X is equal to individual income over 2 times PX, and I've got now 100 individual consumers. So everybody looks identical here. Everybody has the same income, the same preferences, and all I want to do is add up demand for any given price. So what I need to do to find my big X, my market demand equation, is to sum from I equals 1 to 100, my individual demand equations. And of course, that's going to be equal to I income, individual income, over 2 times PX. And the only thing that's indexed here is I income, right? That's the only thing that could potentially vary across consumers. But in this example, we have assumed that it doesn't. So I is the same for all of our consumers. So this is really just 100 times income, right, over 2 PX, which simplifies just a bit to 50 times income over PX. So that would be our market demand in this example. Let's do another example where we have people with different individual demand equations. So here we'll just look at 2 consumers, each with a different demand equation. And I've used linear equations here because otherwise it gets very, very complicated. So in this kind of a situation, we would always use a linear demand curve. So what's happening here, I've got person 1 and person 2, and then I want to add up their demand to get market demand. To do that, first we need to think a little bit more about what the individual demand curves look like. So remember that when we're graphing, it's useful to rearrange so that you have the inverse demand equation. Just makes it a little bit easier to graph. So my inverse demand equation is going to be this for each consumer here. So this is Q2 and Q1. And then I can see easily my y-intercept here at 50. Okay, and it's going to go down to 50. Then for person 2, I've got a y-intercept at 25, and that's going to go out to 100, right? And I can see this number is my x-intercept, this number is my y-intercept. That's where I'm getting those numbers for plotting my demand equations. So now we want to add up over quantity, right? So I can see, pretty easily that if the price is 0, consumer 1's going to buy 50, consumer 2 is going to buy 100, right? And the total amount that we will purchase is 150. So for every price, what I want to do is just add up the quantity consumed at that price. But you can see there's some price above which we stop consuming, And so these aren't exactly just straight line equations. They're actually discontinuous, because it's not to say that if the price of this product was 40, that consumer 2 would buy a negative quantity, right? Consumer 2 would just buy 0. And so this price along the y-axis is actually referred to as the choke price. It's the price at which consumption drops to 0. And so we want to take that into account when we're adding these equations together to get market demand. So market demand is actually going to look like some discontinuous set of functions where above a price of 50, it's 0, right? And there's no demand above a price of 50 because in this example, no consumer is willing to pay more than $50. For prices between 50 and 25, we really only have demand from consumer 1. So this is just going to be Q1 for prices between 50 and 25. And then for prices less than 25, we'll have Q1 plus Q2. Both people will buy some of this product. So what we want to do to characterize demand is to write out, for each of these prices, what our demand equation looks like. Rewrite this here as 50 is less than P. P is greater than 50. Instead of writing Q1, I'm going to write 50 minus P for price between 25 and 50. And then for the last segment, we've got 50 minus P plus 100 minus 4P. So that gives me 150 minus 5P for P less than 25. So this is the set of equations that describes my market demand. And so again, you can see that my x-intercept is 150. Demand goes to 0 at 150. And the y-intercept here is going to be 50. But then there's going to be a kink point at quantity of 25. Price of 25. Halfway down this demand curve, then we start to add on this other demand curve. And so up here, we just have demand from consumer 1, but then down here, we have demand from both consumer 1 and consumer 2. All right, good. So hopefully now you have a better idea about how to add together demand curves. The thing that you want to pay most attention to is that you're always summing over consumption, over quantity, right? So I added together these functions. That's going to be different than summing over price, right? Adding together these functions would mean something very different.